Now, modified Euler method for approximating the solution to the initial value problem. Y dash is equal to f of xy, y of x naught is equal to y naught. Modified Euler method. Now, at the points xn plus 1 equal to x naught plus n into h, n is equal to 0, 1, 2, 3, etc. So, the modified Euler method yn plus 1 is equal to yn plus 1 by 2h into f of xn yn plus f of xn plus 1 y star n plus 1, where y star n plus 1 is equal to yn plus h into f of xn yn. Now apply the modified Euler method. So first example. So this is the equation of Euler method. Equation of Euler method yn plus 1 is equal to yn plus half h f of xn yn plus f of xn plus 1 y star of n plus 1, where y star of n plus 1 is equal to y star of n plus 1 is equal to yn plus h into f of xn yn. So in the case of Euler's method, yn plus 1 is equal to y naught or yn plus h into f of xn yn. In this case, or f of xn yn, in this case yn plus 1 yn plus half h f of xn yn and extra one term f of xn plus 1 y star of n plus 1. Y star of n plus 1 is equal to yn plus h into f of xn yn. Now first example, apply the modified Euler method with h is equal to 0.1 to determine an approximation to the solution to the initial value problem. Y dash equal to y minus x, y of 0 is equal to 1 by 2. Same problem that we have already discussed in this case of by using Euler's method. So we have already solved this problem with using Euler's method. Now we are going to do this problem by using modified Euler method with h is equal to 0.1. Now let h is equal to 0.1, h is equal to 0.1, f of xy, given f of xy is equal to y minus x. So using modified Euler method, y star of n plus 1 is equal to yn plus h into yn minus xn, that is f of xn yn. F of xy is equal to y minus x, so f of xn yn is equal to yn minus xn, and yn plus 1 is equal to yn plus half h, that is h is equal to 0.1. 0.1 divided by 2 into yn minus xn plus yn plus 1 star minus xn plus 1, that is f of xn yn plus f of xn yn plus f of xn plus 1 y star n plus 1. F of xn plus 1 is equal to yn minus xn plus f of xn plus 1 y star of n plus 1 equal to y star n plus 1 minus x n plus 1, that is yn plus 1. Now yn plus 1 is equal to first approximation when n is equal to, which is equal to yn plus 1 is equal to yn plus 0.05 into yn minus xn plus, now replace y star of n plus 1 is equal to yn plus h into yn minus xn minus xn plus 1 minus xn plus 1, now which is equal to, which implies yn plus 1 is equal to yn plus 0.05 2.1 into yn minus 1.1 xn minus xn plus 1, where n is equal to 0, 1, 2, 3, etc. Now our aim is to find the function value at x naught or at x is equal to 1, y1. So step interval or the h is equal to, by using step size, h is equal to 0.1. First approximation y1 is equal to just replace yn with y0 and xn with x0, or substitute n is equal to 0, that is y1 is equal to y0 plus 0.05 into 2.1 into y0 minus 1.1 into x0 minus x1, which is equal to, since x0 is equal to 0 and y0 is equal to 1 by 2, given x0 is equal to 0 and y0 is equal to 1 by 2. Now second approximation, so this is the first approximation, y1 is equal to 0.5475. Second approximation, put n is equal to 1, y2 is equal to y1 plus 0.05 2.5 into y1 minus 1.1 into x1 minus x2, and again the same manner we can find the value y2 by substituting function values. y1 is equal to 0.5475 and x1 is equal to x0 plus h is equal to 0.1 and x0 is equal to 0. Second approximation, you will get 0.5894875, and third approximation, again the same manner we can find y3, that is 0.625, then third approximation, fourth approximation, fifth, sixth, up to 10th approximation y10. We'll get the answer as 0.642959, and the error in this approximation, or using the exact solution, we can find the solution, or we can find the value at y is equal to 1 by substituting x is equal to 1. So direct exact solution at x is equal to 1 is equal to 0.64085, and approximate solution using Euler's method, and the error in this approximation is equal to 0.64295 minus 0.640,859. So the error is very less, very small number. It's approximately is equal to 0.0000 something, some value. So this is the Euler's method for finding solution of a differential equation, solution of an initial value problem at some point x.